AWS Cloud, and specifically we're going to be looking at building secure architectures on AWS. So I know some of you are still logging in and downloading the client and connecting up to the webinar. So I'll get going quite slowly. But first of all, just to introduce myself briefly, my name is Øyvind Roti, and I'm a solutions architect with AWS here in Singapore. But I travel quite a lot to different areas and countries around the APAC region. And today I'm going to share with you about our security architectures and how you can build secure architectures in AWS. The agenda will be roughly me talking through a few slides for 30 to 40 minutes. And that's to give you some of the overview and take a step-by-step approach to building secure architectures. But we do encourage you to ask questions as we go. So we have a questions box that you should see in your webinar client, and I have some of my solutions architects colleagues manning those, and will be able to answer your questions along the way. So if you see something on one of the slides and you want to ask questions about it, or in fact anything related to building secure architectures on AWS, feel free to ask questions in the question box throughout this seminar. At the end, after 30-40 minutes, I'll also see if there are some particularly interesting questions that we may want to share with the larger audience. So I'll pick some of them and probably cover them at the end for everyone to take part in. And we will keep the webinar open for 1 hour, so that will be until 1 p.m. Singapore time today. So even after we finish the broadcast and the webinar part, we'll keep it open for Q&A up until that end. And also, if you want us to follow up with you later on, just let us know, and we'll get back in touch with you after the webinar as well. Okay, so I hope that's okay as an introduction. So let's get started on today's webinar. I'm going to assume that most of you know a little bit about AWS already. This is a 201 series webinar, so I'm not going to spend a lot of time on the background of AWS. If you are wondering about that, I can recommend our 101, an introduction to AWS webinars that you may or may not have seen already. But I will cover just a couple of brief points. The first thing is around AWS being truly global. So we have hundreds of thousands of customers across 190 countries, and on the screen now you can see some of the examples and some of the customers that we've been working with and some of the things that they've been able to do on the AWS platform. So that brings us on to the question of how customers typically use AWS. How do they use our services? So in broad strokes, you could say that we have 3 main ways that customers use AWS. The first is to augment the IT capacity that they run in their own data centers with capabilities like DR, disaster recovery, flexible test and development, as well as bursting for spiky workloads. Secondly, they also move existing workloads from their own data centers into the cloud. And finally, you can build entirely new applications and sites, or in fact, whole lines of business on AWS. But the key is that you don't need to tear down your whole data center and rip and replace everything. Each of our customers have different needs, and our goal is to enable our customer success in the way that fits their requirements best. So often we talk about 6 main benefits of the AWS clouds. And here you see some of them, and I'm not going to go through them all in much detail, but we just keep in mind that with traditional infrastructure, you have to guess how much capacity you'll need over the next 3 to 7 years, and then you have to pay for most of it or all of it on day one. So that ties up money that you could be spending on other things, and it's also very difficult to forecast accurately over a long period of time. So with AWS, you pay for what you need when you need it. And we're also offering this as a lower total cost. And since we invest and operate at such a high scale, we pay less per unit than most other people in the IT industry. So we run our business on a high volume, low margin business, which is also quite unique. And that combination of high scale and low margins allows to pass significant savings along to our customers. So one of the points of this, or a proof point of this, is that we've had 31 price reductions over time since we started in 2006. So let's talk a little bit about our global infrastructure. So our data center footprint is truly global. So we span 5 continents, and we have highly redundant clusters of data centers in each what we call AWS region. So our footprint is expanding continuously as we increase capacity and redundancy, and we're adding locations to meet the needs of our customers all around the globe. So right now we have 9 AWS regions, and in each, if you open up those regions and you count all the availability zones, we have 25 availability zones across the world. So we'll come back to availability zones in a moment, because it's one of the ways that you can help increase resilience in your application. The last data center region that we launched was actually in Sydney. So in the Asia Pacific region, you now have 3 regions. You have the Sydney region, the Singapore region, and also the Tokyo region. In addition to our data center regions, we also have CloudFront edge locations. So right now we have 40 edge locations around the world. The last one we launched was in Seoul, Korea. And these edge locations serve our CloudFront content delivery network, so that it allows you to edge cache or cache content close to your end customers around the world. It is also used to host our Route 53 globally distributed DNS service, and we'll come back to that in a moment. So on top of this AWS global infrastructure, we build what we call foundation services. So hopefully most of you are fairly familiar with these services. It's not the main topic of our talk today. But just to do a quick recap, the 4 main foundation services we have include compute, storage, database, and networking. So within compute, probably one of the more popular service offerings is Amazon EC2, Elastic Compute Cloud. And Elastic Compute Cloud allows you to run virtual machines with the operating system that you want, with the applications that you want in the AWS cloud. So we will spend quite a lot of time today talking about how to apply security architectures to Amazon EC2. In the storage side, we'll also talk about some of these, but you have our object storage service, Amazon Simple Storage Service, S3. You have block devices, Elastic Block Store, or EBS, which allows you to have your C drive or your D drive on your virtual machine. And Amazon Glacier, which is a highly resilient and durable archival solution. In the database space, we have fully managed databases, such as Amazon Relational Database Service, where you can run MySQL, Oracle, or SQL Server in a managed way, so Amazon actually does the patching and the backup for you. We also have NoSQL databases or non-relational databases like DynamoDB, and one of our recent entrants is Amazon Redshift, a fully managed data warehousing solution. Finally, in the networking layer, and we'll come back to some of these a little bit later, we have the Amazon Virtual Private Cloud, or VPC, which allows you to create your own virtual private network inside the AWS region, where you define the IP ranges and can set up very, very granular security controls. AWS Direct Connect allows you to connect directly to your Amazon resources without going over the public internet. And Route 53 helps organize and manage your DNS entries. So with some of those basics out of the way and kind of refreshing your memory of some of the basic AWS services, let's talk a little bit more detail about the AWS platform security. So what we do is we take security very seriously. It's our #1 priority. And our focus and investment in security, and the fact that we incorporate requirements from our most security-conscious customers, then benefit all of the customers on our platform. So all of the requirements we get from very, very security conscious customers, large enterprises and governments, we implement into the platform, and all of you, all of our customers can take advantage of that. So that's a very effective approach to meet enterprise security requirements. One of the ways that we talk to our customers and explain to our customers about our platform security is around relevant certifications. So I'm not going to go into an enormous level of detail of each one of these certifications. And at the end of the presentation, I'm going to show you a link where you can find a lot more detail, or you can contact us for having a one-to-one discussion. But to cover some of the main ones, you'll see here that we have SOC 1, SOC 2, and SOC 3. And SOC 1 focuses really on the processes and controls that AWS performs relevant to our customers' financial reportings. So many of our customers use the SOC 1 as an integral part of their Sarbanes-Oxley efforts and also other security and compliance initiatives. The SOC 2 for AWS focuses on the processes that AWS performs as relevant to controls around security. And SOC 3 then reports on SOC 2, so reports on the AWS security practices, and enables you and your stakeholders to validate that AWS has obtained independent auditor assurance. So the SOC 3 report is actually available on our website, so it's publicly available. The SOC 1 and SOC 2 reports we can make available directly to our customers upon request under an NDA agreement. So if you're interested in receiving a copy of these, please get in touch with us, and we can follow up directly with you on that. I'll also mention just briefly a couple of others. So ISO 27001 certification. So ISO 27001 is a widely adopted global security standard, and it outlines the requirements for information security management systems and provides a systemic approach or a systematic approach to managing company and customer information based on periodic risk assessments. We've also got payment card industry, or PCI, data security standard compliancy at level 1. And for FedRAMP, AWS has achieved 2 agency authorities to operate at the FedRAMP moderate level. So FedRAMP is approved for all the US regions, which means that the US government departments can use our data center regions in the US and not just the GovCloud. So we have one region that is specially created for the federal and local and state government in the US and is ITAR compliant. But with FedRAMP, it also allows US government departments to use the other data centers as well. What's very important to keep in mind is that we keep the same security standards around the world for every region the same. So you also can take advantage of all of these security platform, the AWS security platform, around the globe, not just in the US. So it's the same standard around the world. So having talked a little bit about certifications, I want to come over to a very, very crucial element to understand when you use AWS, and that's called the shared responsibility model. So moving IT infrastructure to AWS creates a shared responsibility model between the customer and AWS. And this shared model can reduce your operational burden, since AWS operates and manages and controls the components from the host operating system and virtualization layer all the way down to the physical security of the facilities in which the services operate. So on this picture that you can see that the areas in yellow, the Amazon covered areas, include our foundation services and our global infrastructure. So in simple terms, that's what AWS take care of. Okay. Then in turn, if we look at the blue section or the top one, you, the customer, assume responsibility and management of quite a few things as well. One of the important ones is the guest operating system. So if you install and run a guest operating system on Amazon EC2, Linux or Windows, you are responsible for updating patches, for example, on that operating system. Okay? You're also responsible for updating and patching your application software and to configure AWS-provided security group firewalls. So AWS provides a lot of the tools for you to use, but it's up to you to make sure that you use those tools in adherence to your security policy. So in the blue section here, we've got a few examples. So you can see at the top we've got customer data. Then we talk about applications and identity and access management. The operating system here refers to the guest operating system, as well as the virtual network and firewall configuration. So we allow you to configure all of that yourself. So it's important for you to understand that it's part of your area of this shared responsibility model to configure it in accordance with your security requirements. We can certainly help you provide guidance if you want from us or answer any questions, but it's very, very important for you to understand what we expect you, the customer, to be responsible for and what Amazon is responsible for and takes care of for you. Finally, the three last blocks in the blue side includes client-side data encryption and data integrity authentication, server-side encryption of the file system and or the data if you want to do that, as well as if you want to implement additional network traffic protection. You can also do that either through services that we provide or our ecosystem of partners that offer a lot of services from low and no cost to enterprise-grade solutions. Having said that, it's also very important to understand that many of our services have lots of included security built into them. So many of these shared security model considerations that you have to look after applies to the EC2 service in particular. So that's normally where we see most of the customers use EC2 and operating their own guest operating systems. So you should carefully consider the services that you choose, as your responsibilities vary depending on the service you use and how you integrate those services into your IT environments, as well as applicable laws and regulations. So it's possible for you to enhance security and meet more stringent compliance requirements by leveraging technologies such as host-based firewalls, host-based intrusion detection or prevention, as well as encryption. I will come back to some of those details in a little while as well. So, having set the groundwork and some of the background for how AWS addresses security, let's go on to how you can secure your cloud applications. Needless to say, we won't be able to cover absolutely every conceivable scenario in the short time we have here, but I encourage you to ask questions in the question box right now, as well as let us know if you want to have a follow-up discussion later on about a particular requirement or a particular question. But in this webinar, we will go through a couple of the scenarios that we see most often. So where I'd like to start off is in the area of resilience and availability. And what I've drawn up on the screen is a very simple, fairly flat application. We can probably assume that this is a kind of a web application. And I just wanted to highlight a few of the areas that you should consider building an architecture to take into account resiliency and availability. Okay. So at the top of the diagram, you can see that there is an icon here showing the DNS of a fictional website called www.example.com. So you can use our Route 53 service to handle DNS lookup. And as I mentioned earlier, our Route 53 service is actually globally distributed. So when you use Route 53 or Route 53, you will get a number of name servers that will be geographically dispersed. And you may remember that I mentioned we currently have 40 edge locations around the world, and the Route 53 servers utilize those edge locations. So by using Route 53, you already have a level of resilience and availability built in there. The second layer is the elastic load balancing service. So the elastic load balancer distributes incoming traffic to multiple servers. So in this case, I've drawn two orange boxes, two web servers, and the elastic load balancer distributes load to them. Now, the elastic load balancer is actually a service. So you don't have to deploy a primary and a standby and then handle any of the failover. The Elastic Load Balancer actually takes care of that as part of its service. So by using the Elastic Load Balancer, you get resilience and availability as part of that service without having to set up any standbys. The other important element about Elastic Load Balancing is it will scale according to the load of your site. So as more users come in requesting more data, the Elastic Load Balancer will scale automatically to address that. You may also note that the Elastic Load Balancer seems to be sending the traffic to two different availability zones. So just a quick refresh here. An availability zone, you can think of it as a data center, a physical data center. So having two availability zones, and in this case we have two availability zones within the Sydney region, means that you are utilizing two different physical data centers separated, and you can deploy your servers and AWS resources in both availability zones at the same time. So in this case, we have a web server in both availability zones, and the Elastic Load Balancer is sending traffic to both of those servers at the same time. So your application is spanning multiple data centers already. So in case of a catastrophic failure, which will impact an entire availability zone, your application can continue working. The traffic continues to be sent to the other availability zone. Another thing to note about AZs or availability zones is that there is very fast interconnectivity between the availability zones inside the region. So sending traffic between AZs is very, very fast and low latency. Typically, when I do my own testing, I see latencies between 0.5 to 1.5 milliseconds. So that's a little bit about availability zones. The next thing I'd like you to notice are these auto-scaling groups. Auto-scaling groups allow you to automatically scale your fleet of servers out and in. So as the load increases, maybe you want auto-scaling to automatically start up, launch more EC2 instances to handle the load. Auto-scaling groups are controlled through policy, so you set the policy, and a simple policy for this scenario might be if the average CPU of all of my EC2 web servers is more than 70%, add 10% more EC2 instances to handle the load. On the contrary, you can also have a rule that scales down or scales in where the load is low. So maybe you have another policy that says if the load, the CPU utilization of my web servers and app servers is less than 45% over half an hour, scale down, take one instance out. So this allows you to automatically scale in and out. And what some people forget about this is it gives you at least two benefits. One is scalability, but the other is also availability. So auto-scaling works very closely with CloudWatch and Elastic Load Balancer. So in case of a failure, let's say if this EC2 instance fails for some reason, auto-scaling will automatically replace that instance with a new one and attach it to the Elastic Load Balancer. So in that way, you can actually have high availability, and even if this happens at night when you're sleeping, you do not have to get up and wake up to manually launch replacement instances if there is a failure. So important to keep in mind, auto-scaling helps you to scale, but also helps you in terms of availability. Moving on, a layer down, we have the database layer. And in this case, I've chosen to use our relational database service. Let me assume, for example, that I'm using our MySQL relational database service. And the relational database service, or RDS, is a managed service from AWS. So it's very easy for you to tell AWS, I want an MySQL RDS database, and I want to have a secondary server, a failover or slave, that I can fail over to in case of critical failure of my master database, or in fact the entire first availability zone. So RDS will set that up for you, and it will even handle the automatic and synchronous disk level replication between the master and the slave database. Okay. So in the case of critical failure in availability zone 1, The secondary or the standby will then be promoted to a master and take over the responsibilities as the master database. EBS, Elastic Block Storage Volumes, are block store features or service that you can attach to your instances. So this would, on a Windows machine, would be the C drive and the E drive and the F drive, etc. So that's where you can store your data, for example, your root volumes and your data volumes. Now, from a resilience and availability perspective, each EBS volume actually has a copy volume inside the availability zone. So if there is a failure of an EBS volume, the EBS service will try to replace that with the shadow volume or the secondary volume, but it only operates within the availability zone. So in case of a critical failure of the entire availability zone, you can also do EBS snapshots. So Elastic Block Store snapshots are point-in-time copies of your EBS volumes that is then stored in the Amazon S3 service. Now, why is that important? I'll talk about S3 in a little bit more detail in a moment, but S3 is accessible to all availability zones within the region. So you can then recover from that snapshot and actually create another EBS volume in the other availability zone from that snapshot. Finally, I'd like to mention CloudFront. Many people don't think about CloudFront in resilience and availability, but CloudFront is our content delivery network. So it allows you to store, many people use it for static data, but you can also use it for dynamic data now, store static data close to your end customer. So our 40 global edge locations will then allow you to cache static content close to your customers to allow for low latency and better customer experience because their downloads and their website load comes faster. But this also allows you to scale because your customers will be accessing these edge locations. And even if there are issues or availability issues with your primary applications, CloudFront can actually help you stay available even in case of failures in the back end. Now, we've only talked about what happens inside an AWS region at the moment, but some of our customers also want to go one step further. They want to have a complete disaster recovery approach in case there is a major event that impacts the entire Sydney region, for example. So to do that, you could also set up disaster recovery locations in other AWS regions. So going into detail about this is outside the scope of our discussion today, but I strongly encourage you to have a look at some of our disaster recovery videos and webinars online and get in touch with us as well if you're interested. But in this case, you can see that this application has pretty much been replicated in two other regions, one in Singapore and one in the US on the West Coast, and that can give you a very, very cost-effective and good disaster recovery solution. One of the benefits a lot of people highlight with disaster recovery on AWS is that once you have established your standby or your disaster recovery region, you can turn off all of the resources in that region, or maybe only keep on a few for database replication, for example. And since our services are pay-as-you-go, even if you have 100 servers or 1,000 EC2 instances on the standby in the DR location, if they are stopped, you're not paying for their hourly cost. So it can be an extremely cost-effective way of having disaster recovery for your enterprise. Okay, so now I'd like to get into a little bit more detail about this and pick out some of the different elements. So the first thing I'd like you to think about are the network security layers. This is quite a comprehensive, we have quite a comprehensive suite of services here, and I think it's worth going through most of the features. And we'll start at the top with security groups. So security groups, many people like to think of security groups as stateful filtering devices or stateful firewalls. When you create an EC2 instance, when you launch an EC2 instance, that instance must be a member of at least one security group. So there is no way you can start an EC2 instance in AWS without it being part of a security group. And by default, that security group does not allow any traffic to come in. So it is your responsibility, this is part of the shared responsibility model, to open up the security group to allow the traffic that you want to access. So what I mean by that is you specify the protocol port and also the source IP range that you want to access, to allow access to coming through that security group. Okay. Now, many of you may only be familiar with the inbound rules for security groups, but in virtual private cloud, something I'll explain in more detail later, virtual private cloud also adds outbound filters for security groups. So in virtual private cloud, you can configure both ingress and egress for security groups. Also in VPC, we have something called Network Access Control Lists, or ACLs or NACLs. This is an additional filter, and this is a stateless filtering device that operates at the subnet level within a VPC. I'll come back to what that means in detail in a later diagram, but this is an additional filter layer which allows you to specify additional rules for incoming and outgoing traffic, and here you can give both allow and deny, so whitelist and blacklist. And finally, we also encourage our customers to use operating system level firewalls if that's in line with their security policies. So on your operating system, guest operating system, Windows or Linux, you can run your own standard firewall software, for example, IP tables, and you control that from a user level perspective. So as you can see, there are many, many layers that you can integrate and configure to really granularly control the access in and out of EC2 instances. The one last thing I would also mention on this slide is if you want to implement intrusion detection type services, so IDS type services, you can deploy those in the host-based mode. So there are a lot of third-party, both free, open source, as well as enterprise software that allows you to deploy host-based IDS solutions, and you can use those on EC2. So if you have a security policy that requires that, or if you would like to do that, that's absolutely an option as well. Just keep in mind that you have to manage that as part of the shared security model. Okay, let's have a look at the architecture that we talked about earlier. And what I've done here is I've made it a little bit more complex, so I've added an extra layer. So what we're looking at here is a typical three-tier web architecture. So we've got the end user, it's coming through an elastic load balancer. We've got web layer, web services layer, and application server layer, as well as database servers in the end. Okay. So security groups that we just talked about, every EC2 instance has to be a member of at least one security group. So in this case, you can see that we have created an EC2 security group for the web servers. We've created another security group for the application servers, and we also have security groups for the database service, in this case an RDS service. So we can then configure the end user, for example, to be allowed to access the front web servers. So in this case, you can see the green arrows there allowing the incoming traffic, presumably on ports like 80 on 443, to the world if this is a publicly accessible website. Something to keep in mind, though, is that end user does not have access to the application and database servers. So the security groups for those servers have explicitly not allowed traffic from the end user to come in. Okay. So that's a very, very important point. But how about traffic from web servers to application servers? So you certainly would like your application servers to receive data from the web servers as well as send data back. So what you can do, security groups have this very, very nice feature that allows you to configure in your security group either your source as an IP range, a CIDR range, or your source can also be defined as coming from members of another security group. So in this case, the application server security groups have been configured to allow incoming traffic, presumably on the application-specific port in this case, if that traffic, and only if that traffic, is coming from EC2 instances that are members of the front web servers. And this is very, very important. That means that you do not have to hard code in the IP addresses of these web servers. And you can think that this is going to save you quite a lot of headache and time. Imagine if you had an auto-scaling group for your web servers and you don't really know at any point in time how many web servers are in operation. So if you are scaling out and adding 3 more web servers, going up to 6, you would then have to either script or manually update the application level security groups to allow those 3 additional IP addresses. Even more importantly, when you scale in, those web servers you no longer want to access or allow access from those IP addresses to your application server security groups. So in that case, you would have to manually or script a way to remove those rules from the security group. So by using this feature of allowing traffic from another security group, you don't have to do any of that. All you have to specify for the application server security group is to allow incoming traffic on a specific protocol and port from the security group that the web servers belong to. Okay. Probably the last thing that I'll mention here, because some people in my experience are not aware of it, I'm just going to go back 2 slides. In here, in Virtual Private Cloud, the Elastic Load Balancer has its own security group. So you can configure the web servers, okay, to only allow incoming traffic from that specific Elastic Load Balancer security group. So that's another way that you can ensure that the only traffic that is allowed into the web servers through the security group is coming from that Elastic Load Balancer. Okay, so moving on, I'd like to talk a little bit more about Virtual Private Cloud. And Virtual Private Cloud was created in 2009, okay? And Virtual Private Cloud is something that I pretty much always recommend to all of my customers, especially enterprise customers, because it really is very similar to how people are used to managing their own enterprise networks in-house. It looks very, very similar, and the language is similar. So VPC, or Virtual Private Cloud, allows you to extend your own data centers. So what you can see here is that we've created a virtual private cloud inside an AWS region. And that virtual private cloud is your cloud. You define the IP range. So you can create up to a 16-bit IP range for your VPC. So that's 65,536 IP addresses. And you can define subnets as well as how those subnets route traffic. So you can, in effect, simulate and create subnets that only allow traffic privately, so only internal traffic, and subnets that allow traffic coming in from the outside world, for example, your data center, or from the public internet if you wish. So to explain this scenario here, we have, again, a typical kind of N-tier application setup inside the virtual private cloud. And we have connected the virtual private cloud to our own on-premise data center, our corporate data center. And there's 2 main ways that you can connect back to your own data center. One is to use what we call the AWS Direct Connect service, which is essentially a leased line or a dedicated circuit from the AWS region to a pairing location close to you. So for example, in Singapore, that pairing location is Equinix SG2. So that means that you can have a 1 gigabit per second port or a 10 gigabit per second port or multiples thereof ports connecting between your AWS resources and your on-premise data center. And the other beautiful thing of it is the direct connect connection is only chargeable by the hour. So if you do not want to traverse the internet in any way, Direct Connect allows you to do that. If you're okay with using an internet connection to your virtual private cloud, but you want to encrypt that link, you can also do that. So you can use IPsec VPN security to establish a point-to-point, site-to-site VPN link between your data center and our data center. So you use your router in your data center, okay? So your Cisco or Juniper router or even a server, and you connect to what we call the virtual private gateway in your VPC. And that actually gives you two tunnels for redundancy that allows you to directly connect to your VPC network. And for your users on your on-premise data center or your own network, the VPC, your virtual private cloud in AWS's region, looks like it's just another data center, just another part of your network. So you'll use private IP addresses, and you can see here that Active Directory is being extended into the virtual private cloud. So you can use Active Directory or other directory services that you prefer to manage all of your resources also in the virtual private cloud. So it really looks like it's just part of your corporate network. The other important thing to note is in this scenario here, there is no internet access. There is no exposure to the internet at all. So all of these subnets in here have the designation of private, which means they are not routed or routable to or from the internet. So a typical scenario I see quite a lot are when customers want to host an internal-only application, for example, SharePoint as a CMS solution. So a lot of customers deploy SharePoint on AWS, and then they either use Direct Connect or IPsec VPN to connect their end users to their SharePoint deployment in AWS. So they're just treating virtual private cloud as another data center. Okay. So moving on. I want to touch upon a few different services and features that are very, very powerful and will help you in securing your application. Probably one of the more important ones, and one that I spend a lot of time with and customers spend a lot of time with, is the Identity and Access Management, or IAM service. So in the very basic level, IAM allows you to create and manage users and groups within your AWS account, okay? And you can give these users unique security credentials. So for example, access keys for RESTful API calls, login and password. So for those of you familiar with our AWS console, the web-based interface, you could actually create user accounts and give separate usernames and passwords to your colleagues and limit their access rights, so that they can log into the AWS console and manage the part of AWS resources that they are responsible for, but nothing else. So, and some people are not aware of this, a very, very cool optional feature is to use multi-factor authentication. You can see a picture of a Gemalto token here. So one way of using MFA's multi-factor authentication is to use a token. The other way is to use an application on your iPhone or Android or other mobile devices. So you can use either the AWS provided ones or Google Authenticator as well. Okay. So by doing that, you can, in addition to username and password or access key, secret key, for example, also require another factor of authentication, which is, for example, a one-time password or passcode from your Gemalto token or your mobile phone. And they're integrated with the AWS services. So IAM also allows you to create policies, and these policies control access to AWS APIs. So I'll talk about S3 access controls in a moment, but IAM allows you, for example, to create a policy that says, allow this user access to this object inside this bucket in S3, but only when they are coming from this IP range, which might be your own personal IP range. So IAM allows you to get very, very granular in terms of access control, and with S3 itself, I think you can, the number of permutations and API calls exceeds the 20 to 30 different types of policies that you can, and API calls that you can make. API calls has to be signed, so you either sign them using an X509 certificate or a secret key. And as I mentioned, IAM is deeply integrated into a lot of our services, for example, S3 policies. The important thing to note here is identity and access management operates at the AWS level. So IAM is not directly usable for your guest operating system or application layer access management. For that, you should use your LDAP or Active Directory, Federation services, etc., to manage your application level and guest operating system access. Extending the identity and access management framework a little bit, I just wanted to touch upon very briefly IAM Federation. So IAM Federation allows you to link your internal directory or identity store with AWS APIs and services. So to do this, you can grant users temporary access to your resources by calling a service that we call the AWS Security Token service. And that service will return temporary security credentials that consists of a security token, an access key ID, and a secret access key. So you then issue the temporary security credentials to the users who need the temporary access to your resources. And important to note is that those users can either be existing IAM users that you have created, or they can be non-AWS users or federated identities. And those users might even be systems or apps that need to access your AWS resources. So I see a lot of customers use this, especially for mobile applications where they might have millions of end devices that need to have access to AWS APIs. S3 integration is a perfect example. So temporary security credentials provide the enhanced security because they have short lifespans and they can't be reused after they expire. Okay. And the access key ID and secret access key that's generated with the token can't be used without the token. So I thought I'd just mention that, especially for those of you developing applications on AWS out there. S3 security, we've talked about quite a few of these, but S3 security has its own built-in access control as well. So that allows you access control at the bucket and object level, and I've included a screenshot there, and this is often the simplest but not a very granular way of giving access. It's kind of like a read-write full control to everyone or only authenticated users type of setup. You as the owner of the bucket have full control, and you also have support in S3 for customer encryption. Okay, so you can encrypt the data before you upload it to S3, or you can use our server-side encryption, but in that case AWS still has the keys. The durability of 11 nines is due to the fact that AWS, when you put an object into S3, replicates that to at least 3 different locations within a region. And it consistently and constantly checks to make sure that all those objects are in a good state, and if it finds some that are not, it will then create other copies. Availability is at 99.99%. So again, since your data is in 3 different locations, S3 is designed to withstand the failure of 2 entire locations. You can add multi-factor authentication to versioning and deletion, as well as use and access detail access logs for whom have accessed what in S3. Getting very close to the end now, I thought I'd just mention a couple more things. One very exciting announcement that we made in 2013 was around a new service called Cloud HSM. So HSM is the hardware security module, and this allows you secure key storage within an AWS region. So the Cloud HSM offers you a tamper-resistant and customer-controlled hardware security module within your VPC. So only you have access to your keys, and it's reliable and durable key storage available in multiple AZs. So if you want to find out more details, you you can check out the AWS Amazon.com Cloud HSM. So finally, before we look at some of the questions and the answers here, I want to, first of all, thank you for paying attention for the last 50 minutes. I also realized that there's no way that we could have covered everything under the umbrella about security in AWS in this time frame. So I want to spend a little bit of time just explaining where you can find more information. The first portal, and hopefully something that you can bookmark straight away, is the Security and Compliance Center. So it's available at aws.amazon.com/security, and it has answers to a lot of security and privacy questions. I would especially recommend you having a look at the Security White Paper and Risk and Compliance White Paper, because it's very, very, very comprehensive in terms of the areas that it covers. So probably by reading those two papers, it will answer almost all of the typical security questions that you've seen. We also have security bulletins and a blog, security blog that you can follow. And we have information about customer penetration testing. So a lot of our customers want to do penetration testing on their resources in AWS to make sure that they are well set up. And we support that. All we ask is that you fill in an online form at the security portal just to let us know that you're doing it against your own resources, so that we don't think that you're doing something that you shouldn't be doing. So much more information is available on the Security and Compliance Center here. The other thing that I would probably mention is our Trusted Advisor service. So those of you with business or enterprise support will already have our Trusted Advisor service available. Trusted Advisor is a service that works in the background, and it sends you recommendations in several areas, including cost optimization. But the one most relevant to our discussion today is around security. So it will give you a real-time view of potential vulnerabilities, and it will give you hints and alert you to say, hey, we've noticed that this security group has, opened up a lot of ports. Are you sure that that's what you really wanted to do? And of course, you can then hide and disable these alerts if it really is what you wanted to do. But it's just one more way that at AWS that we're trying to help you realize some of the things that you might be doing, and give you the chance to have a look and change it. Okay, so I think that's about it for the presentation slides. I've heard that we've got quite a few questions in here, but I also believe that my colleague Stephen has been answering all of them, I understand. In any case, we will keep this open. I'll stop sharing the slides, but we'll keep the webinar open for another 7 minutes in case there are any last-minute questions that are coming in. So continue to ask the questions in the questions panel. Also, do let us know if you want us to follow up with you on the security-related or other AWS matter, and we'd be happy to do so. So once again, thank you very, very much for your attention and talking about security and building security into your applications. And I hope you'll have a very nice day ahead. Thank you very much.